Lesson 10.3, find derivative from a limit definition. This is also kind of a review of something we've done before. We should recognize these three different limit definitions. The one we used from the very beginning when we were learning about limits was this as h goes to 0. That was f of x plus h minus f of x all over h. That's a difference quotient. We had where the derivative of a specific a value gets plugged in, so it's the same thing, but now we have an actual number or a radian measure if we were talking about trig. And then the last one we didn't use as much, but it's just as x goes to a specific number. And so really what you're trying to do is pick out what is the function. So in this first one, it's whatever this is on the end, that's going to be your function. And then on the second one, it's still going to be what's on the end at that specific value. And then if it's in this format, you're just seeing the function actually first at that specific a value. Okay, so let's see what we got. Number one, I had to make this so big to see all this, and then it made the limit really big. So I look at this mumbo jumbo and I think, okay, it's a limit, which is a slope or derivative. I see the x plus h with no value for x. So that tells me it's this first limit definition. And so my function is really just this piece on the end. And so I'm going to write that f of x is really just the function for x minus 5x to the fifth. And all it's wanting you to do is find the derivative. So f prime of x, this is just a simple, that would be 4 minus 25x to the fourth power. And that's all you can do. All right, number two, again, I see as h goes to 0, but I don't see x in there. I see a 4. So this is 5 over, it would have been x plus h. 5 over 4. So my actual f of x function would have been 5 over x. So this is really where x was. And this is then taking x plus h, and that's why it's 4 plus h. And then I'm going to write, so f of x is really the function 5 over x, and that's going to be at x is 4. To take the derivative, I'm going to actually make this be 5x to the negative first power, so that would be negative 5x to the negative second, or negative 5 over x squared. Now we're going to plug in specifically 4. And that'd be negative 5/16. And number 3, we have tangent in here. We see as x goes to a specific value, so that is that last limit definition. And so our function is going to be this 3 tangent of x, and we're wanting to find the slope specifically at 11 pi over 6. Okay, derivative of tangent is secant squared. So it'd be 3 secant squared of x. No chain rule because there's nothing inside the trig part. And then I want to plug in 11 pi over 6. You can use your unit circle. You might have it memorized. I know when I see a 6 in the bottom of my fraction, I think of a 1/6 of pi. Pi is a semicircle, is 180 degrees, so a 1/6 of 180 is a 30. So this is one of the 30 triangles, and I'm almost to 12 pi over 6, which would be 2 pi. So I'm right here. I'm 30 degrees away. I want to find secant. Secant is the reciprocal of cosine. Cosine is always the x value. And so I would have 3 times, I want the reciprocal of this, 2 over square roots of 3 squared. 2 squared is 4. And square root and square cancel. 3's cancel. So I get a slope of 4.